Hi, this is Margo. This is early Sunday evening, February 12th, 2023. I hope everyone is safe and doing as well as possible, and we made it through another week. And I'd like to welcome everyone to the show tonight. This will be my weekly update that I'll be putting on YouTube, going over climate-related items, methane for the week, sea ice, and earthquakes. And I want to start off, though, with Sam Carana post, a recent one. This is from Arctic-News.blogspot.com. And he first posted this on Friday, February 3rd, but we know that from experience that he keeps adding to his posts for maybe 2 or 3 weeks, and that's okay, as you get more material and you keep adding to the post. Now that we kind of know that's what happens, so it's interesting to come back later on, 2-3 weeks later, and see what else has been added. But it's called Dire Situation Gets Even More Dire, and I'm going to go over this because it relates to what we're going to look at in my report tonight. And he starts out by saying sea ice extent is very low at both poles at the moment, and the outlook is that the situation is getting even worse. And here you see the purple line, and it's lowest on record, and this is for the Antarctic. And he says around Antarctica, sea ice extent was 2.23 million square kilometers on February 2nd, 2023. Later in February this year, extent looks set to go below the 1.924 million square kilometer all-time record low reached on February 25th, 2022. So we had record lows last year, but we've got new record lows this year because we're below last year. The Arctic sea ice extent was 13.676 13,676 square kilometers on February 1st, the second lowest extent on record for the time of year, as illustrated by the image below. Second lowest. As the above image indicates, over the next few days, Arctic sea ice extent looks set to reach an all-time record low for the time of year. Conditions are dire. This means that Antarctic sea ice could reach an all-time record low extent later this month, while at the same time Arctic sea ice could be at a record low extent for the time of year. Furthermore, emissions keep rising, ocean heat and greenhouse gas levels keep rising, and extreme weather events are getting even more extreme. Keep in mind that carbon dioxide reaches its maximum warming some 10 years after emission, so we haven't yet been hit by the full wrath of carbon dioxide pollution. Furthermore, an earlier analysis concludes that we have already exceeded the 2 degrees C threshold set at the Paris Agreement in 2015. These dire conditions spell bad news regarding the temperature rise over the coming years. On top of these dire conditions, there are a number of circumstances, feedbacks, and further developments that make the outlook even more dire. Circumstances that make the situation even more dire. Firstly, as illustrated by the image on the right, adapted from NOAA, we're moving into an El Niño. It looks like it's going to be a very strong El Niño, given that we've been in a La Niña for such a long time. Moving from the bottom of a La Niña to the peak of a strong El Niño could make a difference of more than ½ degree Celsius, as illustrated by the image below. Secondly, sunspots look set to reach a very high maximum by July 2025, as illustrated by the next two images on the right adapted from NOAA. Observed values for January 2023 are already well above the maximum values that NOAA predicted to be reached in July 2025. So we're 2 years ahead of the prediction. If this trend continues, the rise in sunspots forcing from May 2020 to July 2025 may well make a difference of more than 0.25 C, a recent analysis found. Thirdly, the 2022 Tonga submarine volcano eruption did add a huge amount of water vapor to the atmosphere. Since water vapor is a potent greenhouse gas, this is further contributing to speed up the temperature rise. A 2023 study calculates that the submarine volcano eruption near Tonga in January 2022 was also discussed at Facebook. Will have a warming effect of 0.12 watts per square meter over the next few years. Feedbacks and developments making things worse. Then there are a multitude of feedbacks and further developments that could strongly deteriorate the situation even further. On top of the water vapor added by the Tonga eruption, there are several feedbacks causing more water vapor to get added to the atmosphere, as discussed at Moistening Atmosphere. So he's got the links to the previous articles that he did. Further feedbacks include additional greenhouse gas releases, such as methane from the seafloor of the Arctic Ocean, and methane, carbon dioxide, and nitrous oxide from rapidly thawing permafrost on land. Ominously, November 2023 temperature anomalies are forecast to be at the top end of the scale for a large part of the Arctic Ocean, as illustrated by the tropicaltidbits.com image below. Some developments could make things even worse. As discussed in earlier posts, the upcoming temperature rise on land on the northern hemisphere could be so high that it will cause much traffic, transport, and industrial activity to grind to a halt, resulting in a reduction of cooling aerosols that are currently masking the full wrath of global warming. Falling away of the aerosol masking effect could cause a huge temperature rise, while there could be an additional temperature rise due to an increase in warming aerosols and gases as a result of more biomass and waste burning and forest fires. A huge temperature rise could therefore unfold soon, causing the cloud's tipping point to be crossed that on its own could result in further rise of 8 degrees C. Meanwhile, humans are likely to go extinct with a rise of 3 degrees C, as illustrated by the image below. Conclusion: the dire situation we're in looks set to get even more dire, calling for comprehensive and effective action as described in the climate plan. And then he lists out the key points down here. And so I'll leave a link below in the show links so that y'all can come and look at this. And now let's move on with our show. We're starting with Climate Reanalyzer for today. This is 2-meter maximum temperatures around the world. We're still seeing the super cold air across northern Canada, Greenland, most of the Arctic Ocean, and a lot of Russia. And then right next to that we've got warm air, see, and the eastern edge of the Arctic sea ice is right under this aqua area. And so when you see all this warm air moving up from the Atlantic, we know that it's going to be affecting the regrowth of the sea ice, along with other things too. And then here's our flat view, and here we have all these whites. This is Argentina here, a lot of whites. And then across the equatorial regions of Africa, we're starting to see some whites here in southern Asia and India, and a lot of whites now going from the west coast all the way to the east coast of Australia. And these whites are at least 40 C or higher. The reddish, kind of the dotted red and white, is 40 C or 104 degrees Fahrenheit or higher. So we're seeing them go up because they're going more into the solid white zone, which is about 45 degrees C. And remember, it's still summertime in the southern hemisphere, and it's still winter time in the northern hemisphere. And here's 2-meter temperature anomaly, and we've been watching this area between Svalbard and Franz Josef Land for about a month or so now. being warmer than normal in the air temperature, and it changes shapes and drifts back and forth a little bit, but it's kind of stayed in this area, and it's really affected the sea ice, and in fact it's melted the east side of the sea ice. It's actually melted a big hole that had been frozen. And then, so we've got browns above Greenland and Canada, and this is over a lot of the area where we have the thickest sea ice. And then heavy browns moving into reddish brown across Russia. And then this eastern Siberia is cold. In contrast, it's moved into like even the light purple color, which over here it's starting at 18 to 24 C, lower than normal. And then from Alaska across the rest of Canada and the US, we've got browns and even reds, even into this kind of dark red, and that's about 16 to 18 C higher than normal. Then we've got just spots of blue where it's colder than normal. And we've had off and on weather. It's been warmer this week, but then yesterday I woke up to 4 inches of snow outside my apartment, and I mean, it's mainly melted now, and it's going to be up, I think, at the 50s tomorrow, and then we've got another cold front coming in. Here's the flat view, and see, same thing, the blues interspersed with the browns, and now we're seeing browns reach out across a lot of Europe too. Australia, you're mainly in the browns, and the Antarctic is heating up, so we've got pink and reds on the southeast edge, and then browns across the interior. Here's our overview. Worldwide, we're up 0.65 C, higher than normal. The northern hemisphere is up 0.88 C. The Arctic is up 1.3 C, higher than normal. The Antarctic is up 0.42 C. Southern hemisphere is up 0.42 C. And the tropics are up 0.53 C. So all the regions are showing higher than normal. And when you see both north and south poles higher than normal, that's a sign of extreme warming. Here's precipitation and clouds. The green is rain, blue is snow, and see this big system coming across the Atlantic, and we've got rain at the coast of Norway. We've had rain at Iceland this week, and see the snow band coming across from Norway over to Greenland. And this big atmospheric blob of rain has been very slowly coming across the U.S. It was in Texas earlier this week, but it seems to be moving very slowly, and I mean, it's just getting saturated. Here's the flat view, and see, we've got rain coming almost to the western peninsula of the Antarctic. We have pink here, which is freezing rain over the Weddell Sea. So that's a sign of warm, warm. You see the pink freezing rain. And then we've got also rain, and look at this straight line. What a weird thing to see, this straight line of the rain and snow coming up to the edge of the Antarctic, and then snow there. This is on that southeast edge where you saw the 2-meter temperature anomaly too, in the pink. So as things heat up, we'll be seeing more and more rain on the mainland of Antarctica, and typically they get about 55 days a year of rain, especially on the West Peninsula, because it's warmer than the other. And here are the jet pieces, and you can see it's all broken, and just massive looping and breaks with just no rhyme or reason to any of this. And this it broke, and it's not going to get fixed. So this is one thing that causes a lot of the chaotic weather and will make it difficult for the farmers to plant the crops and grow them and harvest them. And so this is, we're watching the collapse. We'll look more closely at this in a minute, but this is sea ice and snow cover, and here's where it's melted. See this dark area just between Svalbard and Franz Josef Land. Then we've got a little bit of fringe ice making a cross here where it's refrozen, but these not much extent coming back. It's anyway. And here's sea surface temperature anomaly for yesterday. See all the browns, and we're seeing hints of red now here in this Barents Sea. Once this is now in the sunlight as the North Pole is tilting back towards the sun, so that the black circle of darkness is getting smaller, and so more and more area is coming into the sunlight, so it'll be heating up, and we're already seeing that here. And it's stayed dark brown around the southern tip of Greenland all winter, and So we've got browns, reds, and pinks along the east coast of North America. The Gulf of Mexico is brown, in the brown. Here's the Pacific view. We're getting browns more along the coastline. See, and also this had been blue up to South America, but now we're seeing browns in this equatorial Pacific region as we're moving into the El Nino. And here's the Atlantic view. See, here's this hot spot in the South Atlantic and hot spot south of Africa, and so on. And I want to show, we'll click around. Oh, I gotta get up here. Oh, I forget. I want to show on the global, the round view. Here's the Antarctic, and here's the Western Peninsula with South America here. So this is the Weddell Sea, and see the brown coming up to the Western Peninsula and around a lot of the coastline areas. See where there's no ice and it's had time. This water is just heating up. And here too, next to where the Brunt Ice Shelf calved off. So there's that. Now we'll move on to the methane part of the show, and we're going to start with the NOAA methane data for yesterday, the 11th. We're starting with the METOP-B satellite in the morning at the 1000 millibar level, which is equivalent to surface level. The mean or average was 1841 parts per billion. The high reading was 2154. In the afternoon, the mean was 1841 again. The high reading was 2160. On the METOP-C satellite in the morning, the mean was 1843. The high reading was 2187. And in the afternoon, the mean was 1845, and the high reading was 2249. So here's our weekly charting. Weekly data with the chart over here. And so the 11th averaged out to be 1842.5 parts per billion. That gives us a decrease this week of 1.5. And so here we can see where it went down this week. And on this chart, every line right now, until we get a wider range of temperatures, every between lines is 1 part per billion. So it's just been going up and down since October. And remember, they changed the model at the end of October, and so that's why we're only seeing for this year. And I've decided, well, for right now, I've decided that we reached our minimum here. We had 2 days of minimum exactly the same, January 22nd and January 23rd of 1840.75, and that was our lowest for the winter season. And then it's it'll do some stair stepping, but I think that we're on the upswing now. Usually, what I've seen in the past is we'll reach the minimum either in late December or around mid-January. So this was a little later than that. Here we'll see what happened this week. So here we were on last Sunday's show with 1844.0 for Saturday the 4th. So there was no change that week. And then the 5th it went down 1.5. On the 6th it went down 1.25. On the 7th it went up 2.5. On the 8th it went back down 2.5. On the 9th it went up 0.5. 10th up 0.5. And 11th up 0.25. And so even though we did stair stepping up and down, we ended up still a little bit lower than last week at 1.5 for this level. Now we'll move on to the 487 millibar level, which is the closest we can get to 500 HPA equivalent on CAMS. Back to the Met-Op-B satellite in the morning. The mean was 1910 parts per billion. The high reading was 2437. In the afternoon, the mean was 1912. The high reading was 2498. On the Met-Op-C satellite in the morning, the mean was 1869. The high reading was 2294. And in the afternoon, the mean was 1870, and the high reading was 2202. So here we are on the 487 level. So the 11th averaged out to be 1890.25, which was the same as last week. So no change this week overall. And so I added our lowest point again on January 23rd, and for the 487 level it was 1886.5 parts per billion right here. That was our lowest, and I think we're on a general uptrend now. I mean, we went up 2 weeks in a row and then no change this week, so I think it's on the upswing. So let's see what happened here. Here we were last Saturday the 4th, were 1890.25, and we had gone up that week 2.25. And then the 5th went up 0.25. On the 6th, it went down 1.25. On the 7th, it went up 2.0. On the 8th, it went down 1.5. On the 9th, up 2.5. 10th, no change. And the 11th, up another 2.5. Bringing us back up to where we were last Saturday, so no change overall. So there's that. Now we'll look at the CAMS methane data. We're going to start with we're looking at Saturday, February 11th, starting with the Arctic view and surface level. So not much change this week. Here's our color ledger at the bottom. The data is for Saturday, and the forecast period is Sunday through Wednesday. It takes a second for this to load back up. So we've got in the forecast period, we still have really high releases. Here it comes some mollets. It does kind of retreat at like for Saturday and Sunday, but then comes back into action here really by Monday. And the interior, Russian interior here, see it moves, higher readings start moving across. And we also have this East Siberian Ocean, which is above the East Siberian ice shelf, where Natalia and Igor found, they're Russian climate scientists and researchers, and they found huge methane clathrate deposits in the seabed, in the shallow area around the coastlines, and they've been warning for a long time, most famously from about 2008, about as the water warms up here and the seabeds thaw out, then those clathrates will thaw and we have huge methane releases and even blowouts. And it could be, well, Natalia was saying at one point, 50 gigaton methane bomb could go off at any second. And what that would do would be to heat up the atmosphere so fast that it would pretty much be an extinction level event just within a few weeks. And we are seeing, see the reds, this is coming up through the sea ice. it's not swirling over from Alaska or from Russia. This is coming up independently of these other areas. Watch. Here it comes. See? Now it's moving into the red. Here we are at the end of the forecast period, and it's right there on the coastline of Siberia. And we've got the kind of the bright red and reddish orange. This reddish orange color is 2080 parts per billion, and the bright red is 2100 parts per billion. Let's see. So it's already heating up, and what can happen is when you get a layer of ice and the water is warm underneath, then it traps that warmth in and it can't escape because you've got ice, and so it heats up the seabed. And that's how we can see these higher readings in the wintertime, and then they'll go down in summertime. It doesn't make sense, but that's what happens. And this is still high readings from this Koktovik area. That's a big drilling and refinery, oil refinery there in Alaska. It's a huge area. And we're also seeing yellows as a background color here over Canada. It used to be green, but if you look closely, it's moving into yellows. So the background colors are getting higher, or the readings are getting higher. Now we'll go to the North Pole view. Here we can see the whole northern hemisphere. And if you'd like to support my work, there are two ways. You can either, I have a PayPal link in the description box, and you can donate that way through PayPal, or you could join my Subscribestar page for $5 a month and be a subscriber, and you get notified whenever I put a post up on Subscribestar. And I do daily reporting and almost daily videos, at least, of the methane and the other things I see on CAMS and earthquakes. I do that pretty much on a daily basis, and then I do a midweek update, usually on Wednesdays, which is a mini version of my weekly YouTube update. So if you'd like to see it during the week, for $5 a month, you can help support my work and also be a part of the group over there. And my YouTube channel is not monetized. I don't make any money off of this channel. The only whatever I make is, just from the PayPal donations or my Subscribe Star members. So I'm definitely not doing this for the money. I'm doing it as a service to mankind and the scientific community, to be documenting everything, to be documenting especially the methane and the sea ice, because those are the two big things. And having a record of it. And so we see Europe is coming back to life with methane. Germany, the UK, and see it streaming up over the North Sea. And this Persian Gulf Sea is filled up and spilling over Saudi Arabia. India is filling up, still spilling over in the Bengal Bay. It's not as heavy, but it's still there, and spilling over here in the Arabian Sea. China is filling up, and watch the dark waves moving out. That's very high methane when you see that. Look at that. See the wave. And then here in the US, from Texas east, that line east is has the majority of the methane. Very blobby, and from a lot of different things. The rain will cause the methane to increase, or any precipitation. And also, when it's cold, people have to heat their homes, and so that, however, electricity or heating fuel or gas or wood or coal or whatever, that increases, and that increases the methane production as well. And California is covered up. And now we'll go to the Antarctic view. And what we see here is the main background color is now this darker blue, which denotes 1820 parts per billion. This lighter blue is still a little bit left over of 1840, but also this is where methane has gone down. And once all these leftovers of the background color being 1840, it goes down to 1820, we can isolate where it's coming up around the coastline. Look at this, and this brunt ice shelf, the whole thing. See the methane? And we couldn't see it when the background reading was this aqua color, because it was the same. It was the same reading. So we didn't have the demarcation, but now we do. And so this brunt ice shelf, and then there's this little island in the Weddell Sea. There's methane coming up around that. Also on the Western Peninsula, and down here on the little elbow, next to where it goes up to Pine Island Glacier, and here on this southern edge just west of the Ross Sea, look at that, and here on this southeast edge, see right there, and then the eastern edge, and then this area coming in, that's the Amory ice shelf. You've got methane constantly coming up there, and then here on the north coast as well. So I think it's pretty remarkable to see that. You know, it's not from man-made stuff down here that it's coming up. It could be from algae, you know, the snow gets algae on it. It could be from there are lots of active volcanoes. They found about 100 active volcanoes underneath the Antarctic, and also on the edges, around the edges. So it could be that. Or I'm thinking it could be coming up from the shallow seafloor there, from around the coastlines, like what we have in the Arctic, but just on a lower scale. And here's the global view. And look at the sharp demarcation right around the equatorial line. It goes distinct. It's distinct from the blue, light blue to the dark blue. And we have a little bit of bleed through or smearing here in the Pacific Ocean, where it's warmer further south. And even around like these islands and down to Australia. And our white spot is still showing up here at Beijing, and that's, when you see the white, that means it's above the top reading on the color scale. So it's above 10,000 parts per billion. Here you can see the red, that's in the East Siberian Sea. Now we'll look at 500 HPA. So we can see still heaviest mainly over the Arctic regions. The heavy part is coming further south. We're getting some lighter areas creeping in up here where it's a little bit lower reading. And what happens is as the Earth is tilting and moving into spring and summer position for the northern hemisphere, the methane will redistribute, and you'll see the heavy parts go further south as it starts warming up in the Arctic. And here's total column, where all the levels are added up together through the atmosphere, and you get the highest readings here. China, Philippines, we've got a dark spot here in the Pacific Ocean. See that? Normally we don't see it dark over the ocean. India, this is Turkey area, and we've got some spots here in South America. So there's that. Couple of more things from CAMS. I also track sulfur dioxide, and here's what we have today. We've got our highest reading here at Colombia, South America. This is, they have active volcanoes all the way down, even up in Colombia. Here it is at 500 HPA, and so when it's from a volcano blast, it'll shoot up to this level in the atmosphere, and if it's kind of blobby, usually that's from a volcano. If it's well defined, it might be an indicator of an earthquake coming. And then we've got red up here at Kamchatka. This has been, we've been seeing high readings for about a week now from volcanoes going off up there. Here's the ozone hole over the Antarctic, and you can see the whole continent is in some shade of green, and the solid yellow is 300 Dobson units, and that's considered to be a good layer, an average layer, average number, that once you start going like into the green and yellow here, you're going below that. So we've got 3 layers down below, with the yellow green here, and then the chartreuse here, and then the greener green here. We've got a break coming up in the Atlantic, and a break in the coming up in the Pacific too. Here's the Arctic ozone. Heavy coming from China all the way across. And then it's thinning out even more, coming up this in the North Atlantic, from the UK over Norway and Scandinavian regions. It's moving into the aqua zone 2, which is the next color down. Here's the global view. All these greens, see? So here's the aqua. All these greens. That's all of that. And now we'll move to the sea ice portion. of our show for tonight. Okay, we're going to start with our slideshow from Climate Reanalyzer. These are images I save. Try to save them every day. I think I missed one this week. Anyway, this is sea ice and snow cover for today. And here on this east side of the ice, you can see it's all open water up here, and then some fringy ice just coming down on either side or in between the water there. So let's go through our slideshow. Here we were last Sunday, and you can see that was all frozen across last Sunday. Let's see, all the way across. So we're going to click through. Here's Monday, Tuesday, Wednesday, and you can see the melting starting here on Wednesday. Thursday, see how that's opening up. Friday, Saturday, and then I missed Saturday, so we were at Friday, and then from Friday to Sunday. So a lot of change in this whole area around Svalbard and Franz Josef Land. And then moving to our U.S. Navy models, this is Arctic sea ice thickness for today. Here's our color ledger on the right. And the very light lavender is about 1/2 meter thick, and then it goes backwards through the colors of the rainbow up to this dark red, which is 5 meters thick, and very little of that, almost nothing. And you can see the majority of the ice is in, we're now moving into different shades of aqua coming across the Arctic here. The bright aqua is about 2 to 2.5 meters thick, and then the darker aqua is a little thinner. And the dark aqua is about 1.5 meters thick, and then the next color down from that is the blue and purple. That's about 1 to 1.25 meters thick. And then you have the lighter purple, mainly in quadrant 2 here. And this is the area where the melting was going on this week. You can see the change there. Let's zoom in a little more. Let's see, and this ice that has come back, it's very thin and fringy, just wispy ice. It's also thin here in the Kara Sea. And we can see this aqua bridge coming across now. And a little line of green above Canada and Greenland, and that's 3 meters thick. And just a hint of yellow, which is about 3.75 meters thick. And then the red, bright red to dark red, is 4 to 5 meters thick. And so all that thicker ice from old multi-year ice, it's all gone. You're not going to see that here. And you're not going to see huge areas where it's piling up 10, 15, 20 meters along the coastline. No, you're lucky to see it 4 to 5 meters. And we're seeing thickening here in the tributaries, moving into the aquas, and so on. Now here, off this northeast edge of Greenland is a hole. This forms pretty much every year, and this aqua ice, it's exiting, it's sliding down along Greenland, and there's actually a break here this week. And then here in the Beaufort Sea, we can see it's thickening up into different shades of aqua now. And here's the 30-day animation. This was updated to yesterday, so the data goes back 3 weeks, and forecast period goes out to this coming Saturday. Watch here at Greenland. See? Watch how, look at that, it just slides down. It breaks and it thins. And it's just sliding on down. And in these other areas, we're still seeing a little bit of thickening. And let's see what happens here. It looks like it's going to refreeze on this eastern side just a tiny bit. And you can see this big piece is migrating down to the left as it's also thickening out. And then this piece, it's kind of splitting. The split is from the Lincoln Sea up, and the sea ice east of the Lincoln Sea slides east and down along Greenland, and west of the Lincoln Sea slides west, generally west, towards the Beaufort Sea. So where we saw the methane coming up through the ice here, this is this East Siberian Sea, and right underneath here is this East Siberian ice shelf. So it's right in here where you see the bluish purple. Let's see. There's that. Here's the Beaufort sea ice thickness for today. This is Canada on the right, and here's the bright red and a little bit darker red. That's your thicker sea ice, and that's it. Just along the islands, the coastlines there. And here's a line of green that's 3 meters thick, and your brighter aqua 2 to 2.5 meters thick. And here's a thinner area in the Beaufort Sea, but it's thickening. It's also sliding down. Then we've got a thinner area here in the Chukchi Sea, and this area off the Alaska coast here that has been ice-free for it was ice-free for a long time. It was really late refreezing here, and then sometimes it's been no ice where the ice strip pulled it away, or now it looks like a very thin film there. You can see it pulling away. Watch here. See, that's from the way the ice drift goes. So we're seeing thickening in the forecast period there. And here's the Antarctic. This is so sad. And we're at record low, like Sam Carana was saying. And typically, most of the ice does melt down here in the summertime, and then it refreezes in the winter, and the ice is around the continent instead of on the North Pole. The ice is in the center, and the land is around the edges. So this aqua here, that's what we've got left of the thicker sea ice in the Weddell Sea, and it's still in high melt and just dissolving right before our eyes. And here's the 30-day animation. And again, it was updated to yesterday, so the forecast goes out to Saturday upcoming. And see, it's just whittling away around all the coastlines and here in the Weddell Sea. See how that's just shrinking down, and the area of it is getting smaller. At the same time, it's thinning and breaking apart too. Here's National Snow and Ice Data Center. Oh, I wanted to see if they've got a more current image. Hold on. Okay, I just checked, and this is the latest data. It's dated February 10th, which was Friday. So normally it's just the day before instead of 2 days. But this is sea ice and snow cover, sea ice concentration in the Arctic, and the brown line is the median, so you can see where it's water instead of ice there. And also see the dark here, that's open water. So this corresponds with the other two models that we just looked at. Remember, this was 2 days ago, and there's been more melting since then. So this is open. And here's our refreeze extent chart, and the blue line is this year. The dotted line is the winter of 2011 to 2012. So we're in comparison with February of 2012. And that was a year where it was so low on the extent, and that's kind of our marker for low extent. And we're below 2012, and we're below the median. And it had stalled out a couple of weeks ago, and then it started refreezing. See the angle up, about a 45-degree angle, and then a couple of days ago it stalled out again. So looks like a flat line to me. It's lined up on that line. So the where it's melting on that eastern edge is it's being reflected here, because if it's refreezing somewhere else and we've got a flat line, it means that it's melting somewhere else to counteract the refreeze. Here's the Antarctic. And the blue line is this year. This kind of grayish, dark, kind of gray-green line is last year. And remember, last year was record lows. And now, let's see, we've been below last year since around the first part of December. So for almost 2.5 months, we've been at record low. And it looks like it's starting to level out. And last year we reached low, the lowest point right around the end of February. And this little line, that's where March begins. That's all of those. Now we'll move on to NASA Worldview, and we're going to start here in the Antarctic, and you can see a lot of clouds here. But if you just look around the coastlines, there's almost no ice around any of the coastlines. Here's a little fringe here. And here's the Weddell Sea. And we've been tracking this A68. Which one is this? A76. I get confused with all of our icebergs. We've been tracking this. Here it is. Still intact, and it's under a thin cloud layer there today. And so here are the islands, the South Shetland Islands. And then the tip of the Western Peninsula there. So let's see what's happened this week. Go back to the 5th. It's almost in the same location. This was last Sunday. So let's just click through. Here's Monday, Tuesday, heavy clouds. Wednesday, Thursday, Friday, Saturday. Here we are today. So I would say it's just moved up, just a nudge. It's just nudged up and has been pretty much side to side and not spinning anymore. So I don't know how they're keeping it in one place. A68, once it got out into open water, it was traveling. It went all the way up here. Now, here's the Western Peninsula. See, it's ice-free here. And this little area is what's left of the Larsen B ice shelf. And this whole thing has melted. Here's the Larsen C ice shelf. And we've got clouds here. Let's look. See, it's been cloudy all week. And then coming around, here's the Weddell ice shelf. And so the thicker sea ice is right in here, on the west side of the Weddell Sea. And see, this is all open, and we saw the calving of the Brunt ice shelf a couple of weeks ago, and here's the big piece where it broke off, and this is how far it's traveled. It's kind of staying up close to the coastline, but I don't see that it's anchored in anywhere. So it could move out just any time. So let's go back. Here we were last Sunday. See, it was closer to where it broke off. So we'll click through here. Here's the 6th, 7th, and see, this is breaking up on this right side. And what are we seeing here? I wonder what that line is about. Let's go back. Oh, okay, that was the original outline of the ice shelf. Okay, here's the 7th, 8th, 9th, 10th, 11th, and 12th. So it's kind of a slow mover, and it's kind of dragging these huge pieces along with it. But that's a lot of ice. And then here's the rest of the Brunt ice shelf. It goes all the way up here. And so this is one area where we consistently see the methane coming up. We see that on CAMS. We saw it just earlier. Here's the north side. Here's the east side. And here's the Amory ice shelf. And remember that piece of ice that had been sticking out? That's all melted off. And see the blue? I don't know if that's from algae or what. If anyone has any ideas, I know that the snow can get algae growing on it, and it makes things look blue. Or it could be melting, and it turns blue as it melts. And see, ice free along here. Okay, right down here, another glacier we're tracking is this Totten Glacier right here. It's got a tongue, so let's go back. Cloudy last Sunday. Let's see. Here's Monday, Tuesday. This is a pretty good view. Let's zoom in down here. So we can see this crack all the way across on the tongue and then up. Now I want you to watch this area just to the left here. This is sea ice that had frozen up to the coastline, and it starts to break up. And watch how fast it breaks up. Look, here it is. See? So from yesterday, 7th to the 8th, look at that, the big breakup. There it goes. Here's the 9th. It's moving out. 10th, 11th. It kind of moved back in there, probably from the ice drift. And then today, with all these clouds. It's so weird to see what you think is solid ice for the longest time, and then all of a sudden in one day, it starts cracking up real bad, and then it's gone. So here's some more. This is kind of thicker sea ice down here. Here's the Ross Sea. See how it's open? And here's the Ross Ice Shelf. Here's Ross Island. See? There's Mount Erebus, the volcano. There's the shadow. See? And with the sun going down, so these shadows are going to get longer as the sun slides closer and closer to the horizon. And see all this melted. And then these are rocky areas, and the ice where it flows down, a lot of it is melted, or it's in melt. Now here, see the kind of blue-green shade, and then white over here. So I'm thinking this is thinning and getting ready to melt out. And see this area, that's melted. Here it's melted. Okay, coming around. So this coastline is open. So right around here, this is an area where we see methane coming up as well. And the warmer water, the brown, warmer. Where am I? Getting lost. Okay, we're coming around, and we've got a lot of clouds here. I'm gonna zoom in. Here's Pine Island Glacier. Remember how we saw that sea ice go within just a few days. Here's last Sunday. Here's Monday. That's a good view. See? And this is where it had calved off to a couple of years ago. And you can see the flow of the glacier. And blue again. And these these pieces are icebergs. Part of what had calved off, and then it's thicker, and then when the sea ice, when the water refreezes, these thicker pieces get icebound in there until the thinner ice melts. Oh, I was going to show this week. I got sidetracked. There's the 10th, 11th, 12th. So pretty cloudy a lot of time. But I want you to pay attention here, and right down here, sorry about my voice, this is the Thwaites Glacier, and this west side of the ice. Watch how this breaks up this week. And also up here too. Watch. Let's go. Oh, there's the 10th. Let's go back to the 5th. Okay, see, this had already started coming down. So let's see what happens. Wow, big shift there, huh? Here's the 7th, 8th, 9th, 10th, and big breakup here on the 10th. 11th, too cloudy, and the 12th, and we can't see it. But I'm thinking it's just being demolished in there. Then coming around. And we're back to the Western Peninsula. And this whole west side is also an area where methane's coming up. And now going to the Arctic, and the black area is where it's still dark, and so we can see a lot of the coastlines are coming into view. Beaufort Sea, a lot of that's coming into view. More of the Baffin Bay and Greenland and this east side. Novaya Zemlya is coming back into view. Here's the Yamal Peninsula, and just the edge here is still in the dark. So let's see what we can see right now with the satellite view. I'm thinking it's not going to be that much. Here's the Bering Strait. We can't really tell that much with all the clouds. Here's Alaska. Here's Barrow. And so here we can see the sea ice. And here where it's open around the coastline, or just wispy thin. See, that's wispy thin. And coming on down, there's the ice. And here you can see the cracks. See, but remember, this is the thicker ice sliding down. And here's Canada. Let's see. Yesterday, not much difference. Here's the Baffin Bay. Here's the ice, and then open. And here's the east side of Greenland. And that's about all we can see just from the satellite view. Here's sea ice concentration, and we'll turn on blue marble view. Where you see all the pinks, that means that you've got cracks. It's not solid, not solidly frozen. See, and we've got a few whites here. This is, but more in the pink than in the white. And then here, this is where it's melting on this east side. So we'll go back to last Sunday. And we can see it was frozen across there on Sunday. So here we go. Here's the 6th, 7th. There it goes. See, you can see the whole thing moving. So we've got a hole opening up there in Franz Josef Land. Here's the 8th, and here's the hole, definitely. Then it's thawing or melting up here in the Kara Sea too. There's the 9th, 10th, and opens up even more. 11th, and now it's starting to inch back out. And then here we are today. And we can try the nighttime layer. I looked earlier and couldn't really see that much with it. Sometimes with this layer you can see a lot, and other times it's just more frustrating than it's worth. So here's the east ice edge, and I don't know what these lights are, whether it's reflection in the clouds or what. And what did I see? Anyway, here's the Kara Sea. And here's Komsomolets. And we've got really thin or open water around here. There's the ice. And this is the Laptev Sea. You can see the cracks. See, it's opening up already. And East Siberian Sea, can't see anything really. Here's Barrow, Alaska. See, it's just some days the model is, you know, really can't see anything. And today is one of those days. Now moving on to earthquakes. We've got 195 today, all magnitudes worldwide. And last week in my show, the Turkey earthquakes had just started, and it's still rocking. See, and it was awful. And the death toll, what was the last number I heard? I think it was above 25,000. Very sad. And so it's still rocking. And there are 14 in this picture right now. And it's all forest, so. But let's see what happened this week. 7 days, all magnitudes. Look at this. 182. I thought it was more than that, though. But there's a 7.8 and then a 7.5. Okay, that 7.8 has fallen off the map. And 7.5. Now this is the 6th. They just have just a few from the 5th. And 6.0. And then all these are 4s and 5s. Mainly 4s. So, it just kept going. And, you know, huge, whole cities were just flattened. Buildings flattened. Lots of people buried in the rubble. They've been rescuing people, and every day it's less and less, but they rescued some survivors today. And look how it's spread out. The movement is now up here. This is the country of Georgia. Let's see. We've got 3 here in the forest. So this week worldwide, we've had 1,999 all magnitudes. Here was an Arctic earthquake in the Laptev Sea, 4.6. That came in on the 7th. And then these bigger dots are 5s, lots of 5s. Lots of 4s. Here in the U.S., we had a couple on the Juan de Fuca plate. Uh, 3.4, 2.7, and then these are at the fulcrum point where the San Andreas fault line meets up with the Juan de Fuca plate. So a lot of pressure is here, and so this whole area there were 12, and 3.2 was the largest. We also this week had quite a bit of activity at Yellowstone. 3.5 Kelly, Wyoming, but then up here in this northwest edge or corner, look at this, 84 this week. Most of them were right there, stacked up. So yeah, something's up here. And some days it was like 14 or 8, but you know, they add up, and now 84 in the week. And we're also seeing some larger ones. Look up here. Here's one near Buffalo, New York, 3.8, West Seneca. That was on the 6th. Here's one off the coast of Virginia, 2.6, near Greenbackville. Here's one northwest Georgia, 2.1, at Tryon. Tennessee, 1.8, Vonamore. And here's some activity in the New Madrid zone, 5 here, and there was a 3.1. And that was on the 9th. Normally we don't see them that big. So we're starting to see some larger ones on land. 3.2, Norwich, Kansas. There's Texas. Texas had 55 this week. And I wanted to also show the geysers. They were active. 345 this week here at the geysers, California. So that's higher. And see, all along this San Andreas fault line, and we saw a lot of clustering. Here's Southern California. Here's Searles Valley Ridgecrest, and see, just all over. So that's my report for tonight. I didn't think it would go this long. I recorded it in 2 parts. Okay, now bringing it back to a spiritual perspective. I do believe we're in the end times, and you know, everybody's got to make a choice sooner or later which side they're going to be on, for Jesus and God and good, or Satan and evil. And you know, it's becoming pretty black and white what's what. And anyway, like I said, everybody's going to have to make a choice at some point. And if you don't choose, you'll go by default down with evil. So, anyway, we're in the Old Testament, in the book of Job. Job chapter 18. Then answered Bildad the Shuhite, and said, How long will it be, or ye make an end of words? Mark, and afterwards we will speak. Wherefore are we counted as beasts, and reputed vile in your sight? He teareth himself in his anger. Shall the earth be forsaken for thee? And shall the rock be moved out of his place? Yea, the light of the wicked shall be put out, and the spark of his fire shall not shine. The light shall be dark in his tabernacle, and his candle shall be put out with him. The steps of his strength shall be straightened, and his own counsel shall cast him down. For he is cast into a net by his own feet, and he walketh upon a snare. The gin shall take him by the heel, and the robber shall prevail against him. The snare is laid for him in the ground, and a trap for him in the way. Terrors shall make him afraid on every side, and shall drive him to his feet. His strength shall be hunger bitten, and destruction shall be ready at his side. It shall devour the strength of his skin, even the firstborn of death shall devour his strength. His confidence shall be rooted out of his tabernacle, and it shall bring him to the king of terrors. It shall dwell in his tabernacle, because it is none of his. Brimstone shall be scattered upon his habitation. His roots shall be dried up beneath, and above shall his branch be cut off. His remembrance shall perish from the earth, and he shall have no name in the street. He shall be driven from light into darkness, and chased out of the world. He shall neither have son nor nephew among his people, nor any remaining in his dwellings. They that come after him shall be astonied at his day, as they that went before were frighted. Surely such are the dwellings of the wicked, and this is the place of him that knoweth not God. Job chapter 18. Well, that's pretty straightforward. So, I'm praying for all of y'all. If you haven't given your life to Jesus Christ, I really recommend it before it's too late. And I hope everyone has a good week. And Lord willing, I'll be here next Sunday and do another report. So God bless you. Go in peace. And I will talk to you soon. Good night.